The space-time diagram is in the reference frame of an observer O on Earth. Observer O and spaceship A are initially at the origin. The word line for spaceship A is shown. Question A, calculate in terms of speed of light the velocity of spaceship A relative to the observer O. To find the velocity or speed of spaceship A, it means speed or velocity of the moving reference frame. We use the next formula, the tangent of theta is equal to v over c, where v is the required speed of velocity, c is speed of light, and theta is angle between ct axis and ct primed axis, or it's also angle between x-axis and x primed axis. So theta is here. Choose any point on ct primed axis so that you get a right angle triangle. For example, this point with coordinates 6 and 10, and tangent is what opposite of adjacent. 6 light years over 10 light years, it's just 0.6, so tangent is 0.6, hence v is 0.6 c. And notice that it is measured in light years. It means that if you solve for t, you get t to be in years. So the required speed or velocity is 0.6 c. The next, draw the x primed axis for the reference frame of A, and again angle between x and x primed axis is also theta, and tangent of theta is also 0.6. So we can choose, for example, 10, 6, and plot lines through 10, 6, so that opposite over adjacent is 0.6 as required, and it's theta, and it's x primed, also measured in light years. The next, question B, event E is the emission of flash of light. Observer O sees light from the flash when t is 9 years and calculates the event E is 4 light years away in the positive x direction. Plot the event E on the space-time diagram and label it E. So it's event E, it's emission, and it is emitted where x is 4, somewhere here, so that it is observed by observer O. It's not moving reference frame relative to the Earth at t is 9 years, or ct it's 9 light years, and a flash of light or a signal which is moving at speed of light is represented by a line at 45 degrees. Why? Because tangent is v over c. When v is c, tangent is 1, so it's 45, theta is 45 degrees. And this flash of light is not directed, so it will be in both directions. So we draw a light cone, and to be at 45 degrees, and to meet ct axis at 9 and 4, so 9, 5, so it is emitted at 4, 5, and in this direction also at 45 degrees. Why for a 5? It's because you can see that scale is the same on x and ct, so you can see that 4 units here, 5 plus 9 minus 5, 4, so you get isosceles right angle triangle, so that this angle is 45 degrees as required, and it's also 45. So it's the required event E, and it has coordinates 4 and 5. It's emission of light. The next, determine the time according to spaceship A. It's in a primed moving reference frame when light from event E was observed on A, and it is observed at this point, and we need this coordinate on CT primed axis. And how to find it? Since the scale for not primed is given, we can find directly, we can find this coordinate directly from this graph, this coordinate on CT, and if you do it accurately, it becomes, so its CT is 5.6 light years. Its light is observed by A, but in reference frame relative to the Earth. And we need just to convert or to find the corresponding coordinate on CT primed axis. Notice that scales are different and you cannot use a rule and make a proportion, something like that. For example, I mean that 1 centimeter on CT axis is not the same value as 1 centimeter on CT primed value. But how to convert 1 unit on, let me draw a new, it's CT primed, it's CT. 1 unit, it's always true, 1 unit on CT primed corresponds to, and you draw horizontal line, not slant line or something like that, horizontal line, it corresponds to gamma times 1, or gamma on CT axis, or 1 unit on CT corresponds to 1 over gamma on CT primed. Hence, CT primed becomes 5.6 light years divided by gamma, where gamma is gamma factor, it's what 1 over square root of what 1 minus v squared over c squared, and for v is 0.60, it's 1.25, so it's 5.6 light years over 1.25, and it's approximately, it's 4.5 light years. But if say about time, just t primed or light years divided by speed of light, you get in years, so t primed is 4.5 years. And after leaving, let's rewrite. So question is, determine the time according to spaceship A when light from event E, it means it was emitted, was observed on A. So 4.5 years after leaving Earth. It means moment of time for A. Leaves Earth, and in its reference frame, time is 4.5 years. And that's all for this question.